sophisticated approach to studying the National Electrical Code involves several steps. Firstly, establish a foundation by reviewing the basic principles of electrical theory and safety, and familiarize yourself with the structure and organization of the NEC. Secondly, engage in immersive reading by starting at the beginning of the NEC and reading through it systematically. Pay attention to the code articles that pertain to your specific area of interest and use a highlighter or make notes to mark important sections. Thirdly, break down complex concepts by utilizing flowcharts, diagrams, and other visual aids to simplify technical concepts. Search for online resources, such as articles, videos, and forums, that provide explanations in different formats. Fourthly, practice problem solving by applying the NEC requirements to real-world scenarios. Seek out practice questions, case studies, or online simulations to test your understanding. Fifthly, seek external support by joining a professional organization or attending industry events to connect with other professionals and gain their insights. Consider hiring a mentor or tutor who can guide you through challenging concepts. Sixthly, employ inductive reasoning by identifying patterns and commonalities in the NEC and make inferences and draw conclusions based on the information you gather. Seventhly, use deductive reasoning by applying the principles of logic to determine the meaning of specific NEC requirements and draw inferences from the code language and its implications. Eighthly, practice cross-referencing by referring to other sections of the NEC that are related to a specific topic. Use the index and table of contents to locate relevant information quickly. Ninthly, implement active recall by regularly reviewing the material you have studied. Explain the concepts you have learned to others or write summaries to reinforce your understanding. Tenthly, focus on continuous improvement by staying updated on code changes and interpretations. Attend industry seminars and webinars to expand your knowledge. Studying the NEC is an ongoing process that requires patience, consistency, and a willingness to engage with the material in various ways. By following these steps, you can develop a deeper understanding of the NEC and become more proficient in its application. Remember to consult the latest edition of the NEC for the most up-to-date requirements. Always prioritize safety and consult with qualified professionals when working with electrical systems. Understanding the NEC is crucial for ensuring electrical installations are safe, efficient, and compliant with regulations. The NEC is a comprehensive document, and mastering it takes time and effort. However, with a strategic approach, you can significantly improve your understanding and application of the code. Let's delve deeper into each of these steps. Establishing a strong foundation in electrical theory is paramount. This includes understanding basic concepts such as voltage, current, resistance, power, and energy. Ohm's law, which states that voltage equals current times resistance, is a fundamental principle that underpins many electrical calculations. Understanding series and parallel circuits, as well as impedance, is also essential. In addition to electrical theory, a solid understanding of electrical safety is crucial. This includes knowledge of grounding and bonding, overcurrent protection, and safe work practices. The NEC provides specific requirements for grounding and bonding to minimize the risk of electric shock. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage due to overloads and short circuits. Safe work practices, such as de-energizing circuits before working on them, are essential for preventing electrical accidents. Familiarizing yourself with the structure and organization of the NEC is also important. The NEC is divided into chapters, articles, and sections, each covering a specific topic. Understanding how the NEC is organized will help you quickly locate the information you need. The NEC also includes an index, which can be used to find specific topics or keywords. Immersive reading involves reading through the NEC systematically, starting at the beginning and progressing through each article and section. While this may seem daunting, it is an effective way to gain a comprehensive understanding of the code. Pay attention to the code articles that pertain to your specific area of interest. For example, if you are working on residential wiring, you should focus on the articles in Chapter 3 that cover wiring methods and materials. If you are working on commercial wiring, you should focus on the articles in Chapter 5 that cover special occupancies. Using a highlighter or making notes to mark important sections is a good way to keep track of key information. You can also use different colors to highlight different types of information, such as requirements, exceptions, and definitions. Breaking down complex concepts is essential for understanding the NEC. Flowcharts, diagrams, and other visual aids can be used to simplify technical concepts. For example, a flowchart can be used to illustrate the steps involved in calculating the ampacity of a conductor. A diagram can be used to show the different types of grounding systems. Online resources, such as articles, videos, and forums, can provide explanations in different formats. These resources can be particularly helpful for understanding complex or abstract concepts. Practice problem solving is a critical step in mastering the NEC. Applying the NEC requirements to real-world scenarios will help you solidify your understanding of the code. Seek out practice questions, case studies, or online simulations to test your knowledge. Work through these problems step by step, carefully considering all the applicable NEC requirements. This will help you develop the skills you need to apply the NEC in your daily work. Seeking external support can be invaluable, especially when dealing with challenging concepts. Joining a professional organization such as the Institute of Electrical and Electronics Engineers or the International Association of Electrical Inspectors can provide access to a network of experienced professionals who can offer guidance and support. Attending industry events, such as trade shows and conferences, can also be a great way to connect with other professionals and learn about the latest developments in the electrical industry. Consider hiring a mentor or tutor who can provide personalized guidance and support. A mentor can help you navigate the complexities of the NEC and provide insights based on their own experience. Inductive reasoning involves identifying patterns and commonalities in the NEC. As you read through the code, pay attention to the recurring themes and principles. For example, you will notice that the NEC consistently emphasizes the importance of safety and overcurrent protection. Identifying these patterns will help you develop a deeper understanding of the underlying principles of the code. Deductive reasoning involves applying the principles of logic to determine the meaning of specific NEC requirements. This requires careful reading and analysis of the code language. For example, if the NEC states that all electrical equipment shall be grounded, you can deduce that this requirement applies to all types of electrical equipment, regardless of their location or application. Cross-referencing involves referring to other sections of the NEC that are related to a specific topic. The NEC is a complex document, and many topics are covered in multiple sections. By cross-referencing, you can gain a more complete understanding of the topic. For example, if you are researching the requirements for grounding, you should refer to Article 250, which covers grounding and bonding, as well as other articles that address specific grounding requirements for different types of equipment. Active recall involves regularly reviewing the material you have studied. This will help you retain the information and prevent it from fading from your memory. Explain the concepts you have learned to others or write summaries to reinforce your understanding. Teaching others is a great way to solidify your own knowledge. Continuous improvement is essential for staying up to date on code changes and interpretations. The NEC is revised every 3 years, and it is important to stay abreast of these changes. Attend industry seminars and webinars to expand your knowledge. Read trade publications and online resources to learn about the latest developments in the electrical industry. Remember, studying the NEC is an ongoing process that requires patience, consistency, and a willingness to engage with the material in various ways. By following these steps, you can develop a deeper understanding of the NEC and become more proficient in its application. Consider the importance of understanding conductor ampacity calculations within the NEC. Article 310.15 and associated tables provide detailed guidance on determining the allowable ampacity of conductors based on factors such as conductor size, insulation type, installation method, and ambient temperature. These calculations are crucial for ensuring that conductors are not overloaded, which can lead to overheating and fire hazards. For example, NEC Table 310.16 provides the allowable opacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius in free air based on ambient air temperatures. Understanding how to use this table is essential for selecting the correct conductor size for a given application. The NEC also provides adjustment factors for opacity when multiple conductors are installed in a raceway or cable. These adjustment factors are necessary because the heat generated by multiple conductors can raise the temperature of the conductors and reduce their opacity. NEC Table 310.15b3 provides adjustment factors for more than 3 current-carrying conductors in a raceway or cable. In addition to opacity calculations, it is also important to understand the requirements for conductor overcurrent protection. The NEC requires that conductors be protected by overcurrent devices, such as circuit breakers and fuses, that are sized to protect the conductors from overload. The overcurrent protection device should not exceed the opacity of the conductor. NEC Section 240.4 provides general requirements for overcurrent protection of conductors. The NEC also includes requirements for conductor identification. Conductors must be identified by color coding or other means to indicate their purpose. For example, grounded conductors must be identified by a white or gray color, and equipment grounding conductors must be identified by a green or bare color. NEC Section 310.8 provides requirements for conductor identification. Understanding voltage drop calculations is also crucial for ensuring proper electrical system performance. Voltage drop occurs when the voltage at the end of a circuit is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or fail to operate properly. The NEC recommends that voltage drop be limited to 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using Ohm's law and other formulas. The NEC provides guidance on voltage drop calculations in informational notes. Another important aspect of studying the NEC is understanding the requirements for grounding and bonding. Grounding is the process of connecting electrical equipment to the earth to provide a low impedance path for fault current. Bonding is the process of connecting different metal parts of an electrical system together to create an electrically conductive path. Grounding and bonding are essential for minimizing the risk of electric shock. NEC Article 250 provides comprehensive requirements for grounding and bonding. The NEC also includes requirements for wiring methods and materials. Wiring methods refer to the way in which conductors are installed and supported. Wiring materials refer to the types of conductors, cables, and raceways that are used in electrical installations. The NEC specifies the types of wiring methods and materials that are permitted for different applications. NEC Chapter 3 provides requirements for wiring methods and materials. Finally, it is important to understand the requirements for special occupancies such as hazardous locations, healthcare facilities, and data centers. These occupancies have unique electrical requirements that are addressed in specific articles of the NEC. NEC Chapter 5 provides requirements for special occupancies. By mastering these key concepts and consistently applying the principles of inductive and deductive reasoning, you can develop a deep understanding of the NEC and become a highly skilled electrical professional. Remember to always prioritize safety and consult with qualified professionals when working with electrical systems. The NEC serves as a vital resource for ensuring the safe and efficient operation of electrical systems, and a thorough understanding of its provisions is essential for anyone working in the electrical industry.